Hello, welcome to Zigmatech Learning Hub. I will be your instructor for physics. For this class, we are going to be taking our exercises from ExamGuide app. If you don't have the application already installed on your device, I will want you to download the app in order to follow along in this class. ExamGuide is a leading educational app that helps students prepare adequately for various exams like UTME, post-UTME, WEAC, GCE, KCPE, IJMB, JUPEB, KCPE, BECE, JSCE, NCEE, NECO, etc. You can download the app from www.examguide.com or Google Play Store. Please subscribe to our channel and turn on the notification bell and get updated on new videos. Are you ready for this class? Okay, let's get started. Today we are going to be looking at physical quantities. In physics, physical quantities is a very important aspect of physics. Anything you want to learn in physics, if you are not conversant with this, then you've not started the learning of physics. Now, the question is, what is physical quantity? Physical quantity are those quantities that can be measured. The question should be, what is quantity, by the way? For example, we have velocity is a quantity. You know, all those formulas you have in physics, we call them quantities. For example, momentum is a quantity. Speed is a quantity. Time is a quantity. Acceleration is a quantity. These are called quantities. Now, why do we have physical quantities? Because they have measurable values. You know what I mean by that? That means they can be measured. For example, you can measure the volume of water you are to take. You can measure the time you spent on this class. You can measure the area that you have to occupy. So these things or these quantities are what we call physical quantity. Now let me tell you, in fact, let me just beg you, on no account will you have any problem on physics without writing its unit. Because this quantity, for example, when we talk about velocity, which is V is the quantity, then what makes this V what it is? Somebody can come and call it volume. Somebody can come and call it Victor or Vincent. But what makes this V to be this velocity is what is called unit, which is meter per seconds. In this class, we are going to treat this. So what makes this special? For example, look at this. If you have this, what will you say? If you are somebody from this part of the country, you will know that this is a symbol for money. Now, if you have this, you know that this is a symbol. So these symbols are what we call unit, which is different or which differentiate one quantity from the other. So what I'm saying is every physical quantity has what is called unit, and this unit is what differentiates one quantity from the other. For example, when we talk about volume, volume is V, right? But volume is measured in meter cube. So these are the things we want to look at in this class. Now, in this physical quantity can be classified into two. So now, types of quantity in physics. Let's say types of quantity. Now, there are two types of quantity. The first one is called fundamental. Or we'll call it basic quantity, fundamental quantity. And number two is called derived quantity. So these are the two types of this physical quantity, like I said. Now the question is, what is this fundamental quantity? And then which one is called derived? Now the first fundamental quantity is called, let's start with time. Then another one is called mass. And I will tell you why they are called fundamental quantity. That means they are basic They are the basis which other quantities can be formed. They are on their own untouchable. Then the next one we'll have is length. I will permit me to put distance because this confuses a lot of students. When we talk about length, we are talking about distance, we are talking about displacement. We are also talking about depth. You know, students get confused. We are talking about radius. We are talking about height, etc. Why am I saying this? Because all of them have the same unit for measuring them. They are all measured in meter. So the fourth one, we talk about temperature. Then we talk about amount of substance in mole, amount of substance, which is the fifth one, or let's say electric current, electric charge, all right? And then amount of substance. So these are called fundamental quantities. Their quantity is T. When we talk about time, is T. Mass, this one is the mass. Then L is used to represent the length. Then this temperature can also be used as K for Kelvin, and electric one, which is E. So these are the letters when we are talking about the quantity. So now, instead of writing derived unit here, let's talk about their unit, which is very important. What is the unit for measuring time? The unit for measuring time must be in seconds. That is called the SI unit. This SI unit is called the standard international unit, which is agreed by the whole scientists all over the world that is going to be the unit for measuring time. I know time can be measured in minutes, can be measured in hours, but most of the time when we're talking about SI unit, the time for the SI unit for time is seconds. Mass is kilogram. I hope some people can also talk about gram, talk about tone, and talking about other things. But for SI unit is kilogram. Length is measured in meter. Then temperature is measured in Kelvin, which is Kelvin. One electric charge is measured in ampere, which is A. This is Kelvin, all right? So this one is seconds, kilogram, meters, Kelvin, and ampere. Now, the other one, which I call derived unit, every other thing you know in physics called formula, which is not part of this, is called derived quantity. You can name them: velocity, speed, acceleration, momentum, force, energy, intensity. Name them. Every other thing you know in physics, they say is formula. Those ones are classified under derived quantity. Now, for the sake of this lesson, let's just give you a few examples of the derived quantity. Now, I can't bring unit because that is looking for trouble. I can't bring in their unit because their unit is the mathematics we are going to solve in this lesson. The first one, let me start with the simplest: area, volume, let's say speed or velocity, or let's say force, pressure, momentum, acceleration, very important, etc. So these are called derived quantity. Now, what's the unit? I don't know. We are going to find out. And that is why we call it derived quantity, because their unit came from this place. But remember, because we already memorized that, when we talk about area, people will always talk about cm square or meter square or kilometer square. Remember, the SI unit is this one. So all these ones are the ones, you know, mostly in primary school books or your secondary school books. They will tell you, find the area, and they will give you in cm square. So the question is, why the 2 on top, and how did it come? Then when we talk about volume, you said that volume is cm cube or meter cube or kilometer cube. How? How did they come in? We are going to talk about it. That speed is meter per seconds. Or sometimes people will use cm per minutes, sorry. All this is what we are going to treat now. Now the question is, how do we find the unit? Remember, these units, these ones are the ones you must memorize. I mean, when they ask you what is the unit for measuring time, you should know it's seconds or minutes or hour, but SI unit is seconds. What's the unit for measuring mass? You should say is kilogram. What's the unit for measuring distance? You should know is meter. Then temperature is Kelvin, electric charge is ampere, and then amount of substance is mole. These ones you can just memorize it and put it in your head, but these ones are born out of mathematical derivative, and that is what we are going to do. Now the question should be, how can we derive these units? All right, the first thing we have to start doing is, how do we derive the units of these quantities which I've listed? And then we can go on and on by putting Young modulus, because this is the problem, Young modulus. This is the problem students have. When you give them a question to solve, put the unit at the end of the class, at the end, which carries a mark. And you see after solving, they will just leave it. We'll call it mathematical phrase. For example, they ask you to find speed. It says V is equal to 10. What's that? 10 what? Then you are confused. You say somebody, take 10. 10 what? Is it 10 naira? Is it $10? Is it 10 cm? Is it 10 cm cube? You need to specify it, and that is why this topic is very important and you have to pay attention. Let's go on. Now we are going to start with the first one. Derive the unit of the following. Please, they are already here. They are already here on this part of the screen. So look at it. We are going to be doing it. So I'm going to start with the first one, which I'm going to call solution. All right, I'm going to give you steps on how you can achieve this. And then the first one is, you must know the formula. Step 1. You need to know the formula of the quantity to be derived. So, step 2 is, you need to be able to find the unit of each of the quantities that form the formula. Then substitute the units of the formula. Yes, let me put it this way. Substitute the unit of the formula. Step 3, which is the last step, simplify what you have in step 2. All right, these are the 3 major steps you must follow. You must follow to be able to get the units of this done. Let's start with the first one, area. Area. So you need to know what the formula for area. Formula for area is what? Length times length. Length times length. Or people say is L square. All right? This is the step 1. You have written the formula. Step 2, what is the unit of length? Fundamental quantity now comes in. Those ones, you don't change them. What's the unit of length? Is what? Centimeter, right? No, SI unit is meter. So you put meter here. These times, you also follow time. In mathematics, you just do something based on what you are told. Then the next one is meter, right? This step 2. Substitute the unit of the formula. This step 2. Then what is the step 3? Step 3, you simplify it, right? Step 3, you simplify it. Then how do you simplify m times m? M times m is given as what? M squared. Therefore, SI unit, or let's say unit of area is meter square. And that is why whenever you solve a problem in area, your answer must be either centimeter square or meter square. All right, I hope that is clear. Let's go to the next one. The next one is volume. The next one is going to be volume. Okay, let's go down. Volume. Remember the steps. What's the formula for volume? Length times width times height. There comes the confusion. Remember, length and height, I wrote them down as the same quantity. They have the same quantity because they have the same unit of measurement. Even width, because that was why I wrote etc. If you can go back a little, where I listed the quantities of the fundamental quantities, you will see I wrote length, I wrote height, and I wrote etc. etc means that width is also part of it, which is measured in meter. Now, we go further. Step 1, I've written the formula. Step 2, you write the unit of m. The unit of length is m. Times is there, you put your times down. Width is also meter, or sometimes called width, some people call it breadth. Then times height is also meter. Meter, m times m times m is given as m cube. All right? So this is m cube is the unit of volume. That is why some people will give you cm cube, meter cube. However it is, that 3 on top must be there. If you don't put it, then you are not writing a volume. Imagine you are asked to find a volume. You said that the volume of a body is 30 cm. You know what you have said? You just said that this volume is length because cm representing length. Until you put 3 on top, then you are talking. It's okay. You are talking about cube, volume. Okay, let's move. Let's do a few of those in the other ones. Let's go to acceleration, because maybe I will not be able to do all of them, but then there are some you are going to do by yourself. But let me do this: speed, force, and acceleration. Let's see. Let's do speed. What is speed? Speed is defined as distance over time. All right, distance over time. You still do the same thing. This is the formula. Step 1, you have written the formula. Step 2, substitute the unit of the formula. What is the unit of distance? It is given as meter. You put your line. It's as simple as that. What's the unit of time? Is seconds. You write S. Then you finished. And that is why in physics, they say that SI unit of speed is what? Meter per seconds. That is the unit of speed. Now let's do force, and I will tell you why. You know. If you get down to force, what is the formula for force? Formula for force is mass times acceleration. Let me do acceleration first, so that we know where we are coming from. Okay, in acceleration, we are talking about change in velocity over time. Or sometimes they will say v minus u over time. Or remember, change in velocity means the unit of velocity is meter per seconds. Dividing, because this is a divisional sign, time, the SI unit of time, okay, it's a basic quantity or fundamental quantity. The SI unit of time is seconds over 1. Remember, if you want to solve a fraction, the one on the right hand side with the divisional sign will change. 1 will go up, S will come down. So I have S, M over S times 1 over S. And this is equal to M times 1 is M. S times S is S squared. And you see that, and that is why acceleration is always given as meter per second square. Sometimes they will say acceleration is ms raised to power minus 2. This is another way of writing this. Then if you have issue with that, you can also look at a lesson on indices. It will help you to understand this, to be able to do this. Okay. Now, finally, let's do force. Then you can do some other ones there. Let's do force. Then the unit of force, the formula for force is mass times acceleration. Now, what is the unit of mass? Is kilogram. What's the unit of acceleration? Is meter per second square. And if you do that very well, you are going to have kilogram over 1 times mass meter over x square, and which is something as kilogram m all over x square. Or they can put it as kilogram meter s raised to power minus 2. Now, this is a derived unit of force. However, it is not the SI unit of force, because scientists agreed, since Sir Isaac Newton was a man that explained much about force, so they found this, they thought it would be very honorable to use the SI unit of force to be named after him. And that is why we say that SI unit of force is Newton. Is Newton. SI unit of force is Newton. N, capital N, capital N. So you can now say that 1 Newton is the same thing as kilogram meter per second square. And that is it. So there are some other derived quantities which do not have a particular derivative in terms of the basic unit. For example, frequency. Frequency is measured in hertz because it was used to name after the man that defined and gave a better explanation of frequency. And when you talk about energy or work, is also measured in joule, joule. So that is also to use to honor the man that defined work and energy. We have come to the end of this lesson, but before we go, let's take some exercises from ExamGuide Learning app. The first question here is from the ExamGuide Learning app. We have the first question here, which says, which of these units is derived? Which of these units is derived? So the options given there include coulomb, mole, ampere, and Kelvin. So if you look at the fundamental quantities, coulomb is not there. So if coulomb is not part of the fundamental quantities, then it is derived. Therefore, the answer is A. Option A is the answer, because this one now, this coulomb, is the quantity of charge, so which is measured in coulomb, and quantity of charge is not derived quantity. So that is why the option is A. Okay, let's check number 5. Now, say, which of the following dimensions represent impulse? Okay, if you look at impulse is given as force times time. All right? Impulse is force times time. Another thing for impulse is change in momentum, which is mv minus u. Now, we have options there, mlt raised to power 2, then mlt raised to power minus 1, and ml. So what we are going to do now is, I'm going to look at the dimension of this, and I'm going to tell you what I mean by dimension, because they didn't really talk about units. It's dimension that they are talking about. Now let's go get it done. Now on this first one, force is the same thing as saying mass times acceleration, then times time. Okay, mass is capital M. According to the option you are seeing there, M is the mass. Then acceleration is this. Remember, acceleration is meter per second square. In dimension, this meter is L per S is time square. It's just the same thing, just that you are using the first letter of the quantity in this case. So, and this is going to be multiplied by L all over T square. Permit me to use this. I'm not using per, I'm using divisional sign for the sake of the simplification. Multiplied by time is capital T over 1. Let's simplify and see if we are going to have any of the options given. Okay, in this case, let me do it very simple. Times L over T times T. T times T is T square times T over 1. T, we take out 1T. So we have ML all over T. It can also be written ML T raised to power minus 1. Do we have this option? And that should be option C. So option C is the answer. All right, let's take another question here. The next question we are going to, let's look at number 9, which is related to this question we are looking at. We have force is Newton. We have torque. Look at the force there. Force is given as Newton as the unit. You know, this is according to Newton, you know. Then we have torque. Torque, which is given as Newton per meter. Newton per meter. And we have current. This is the first one. This is II. And we have current. Current is given as this capital I, and this is represented as ampere. These are the units of, this is force. The unit of force is Newton. This is torque. Torque, when we talk about torque, we are talking about a force that leads to rotation. You know that force can lead to a movement in a straight line. But when any force leads to turning, we call it torque. Then this is current, which is measured in ampere. And we have the last one, which is IV. And that IV is power, which is measured in watts, Alexandria watts. So, they say, which of these written here, which of these are the correct SI unit of the quantities indicated? Okay, which of them is the direct, which of the above are the correct SI unit of the quantities indicated? All right, this is correct, and this is correct. So this is not correct. And the option there is what? The option is, this is I is correct, this is correct, and this is correct. We have I is correct, 3 is correct, and V, yes, the option is D. 1, 3, and 4 only. These are the correct options for this question. Okay, let's check number 10. Okay, in this question now, we are saying the dimension of Newton's gravitational constant is m raised to power x, L raised to power y, and T raised to power z. You say the value of x plus y over z is. We are going to look at it. Now, when we talk about gravitational constant came from this. Remember this equation called Newton's law of universal gravitation, which says that the force of attraction between two masses is directly proportional to the product of the masses and inversely proportional to the distance separating them. That is so it's given as F, G, M1, M2 all over R square. So this is the equation for this. Now, what am I going to do? I'm going to make G the subject formula because that G is called Newton's gravitational constant. So this is the target variable. G is the target variable. And this is called the Newton's gravitational constant. I'm going to make it the subject formula, and that's going to be, G is going to be equal to FR square all over M1, M2. So now that I've made it the subject formula, which is in line with the steps I gave you at the beginning of this lesson in terms of derivative of quantities, force is in Newton, right? And then R is radius, and radius is measured in meter. So I'm going to say meter square. all over. This m is mass, and mass is kilogram. Another mass is kilogram. So kilogram times kilogram is kilogram square. Now, and this is the same thing as this function given, which is given as m. They said that this is equal to m, which is x, and L raised to the power y, and then t raised to the power z. Now, and then we are asked to find this. We are asked to find x plus y over z. So what do we do at this point? Now, the question should be, what will I call x in order? But before that, we have to remove this Newton. This Newton is our problem. We have to express this in dimension. That's the best thing to do. We have to express all of this in dimension. So let's do it first, because that will be our best. Newton is called mass, which is kilogram and meter per second square times meter square all over kilogram square. Now, this is kilogram, and it means capital M, because kilogram is a unit of measuring mass, and mass is the dimension we are looking at, because this question is about dimension. So meter is L. This is S, which is T minus 2. Yes, because meter per second square is something as saying meter S minus 2. So this is meter is for, this is meter, which is length. This is seconds, which is for time. And then times, this is meter, L square, all over. Kilogram is for mass, which is capital M square. All right, now let us simplify before we make that. To simplify this, this M we cancel. You know there are two M here, so one of them is gone. So you have L, T raised to the power 2, L raised to the power 2, all over M. Or it's going to be M raised to the power minus 1, L raised to the power 1, no, this is 1. 1 times 2 is, 1 plus 2 is 3. You know, according to the power of indices, according to the law of indices, when you have the same base, the powers will add. So L1, L2 means L raised to the power 3. And T is the time is measured, is raised to the power minus 2. Now look at it there. You have M. M, what is the power of M? And that is minus 1. X is minus 1. What is the Y there? Y is representing L. Y is representing L, and that Y is 3. And then what is Z? Z is representing minus 2. Z is minus 2. Now, the question is, how can I find X? Okay, according to the question, we say we find X plus Y over Z. Now, X is minus 1. Plus Y is 3 all over minus 2. So we should find the value of this. Now, minus 3 plus 2. That means plus 3, take away 1 is 2. That is 3 minus 1 is 2. All over minus 2. 2 we cancel 2. We have minus 1. That is option A. Thank you for participating in today's class. You can practice more questions using the ExamGuide app. The app scores and gives a detailed explanation of all the questions at the end of your practice test. You can learn a particular topic of interest with different modes like study mode, mock mode, and practice mode. It also has other features that makes learning fun. It is a must-have for all serious students. Download from www.examguide.com if you don't have it yet. See you in the next class. Don't forget to subscribe to our channel, hit the notification bell, and share the video to people that will benefit from it. Bye.